Okay, so let's start again. The three physical factors that influence the ease of air passage and the amount of energy required for ventilation is airway resistance, alveolar surface tension, and lung capacitance. So what is the major non-elastic source of resistance to gas flow? It occurs in the airwaves. Anybody know what that is? Starts with an F. It is friction. It's essentially that kind of resistance of movement. It happens when you rub your hands together. The heat that you feel when you rub your hands, that's a result of energy that gets changed or into heat from friction. And so overall, you have this equation for it. It's your force, F, equals essentially the change in pressure divided by R, which is resistance, right? And so when we're looking at this delta P here, this pressure difference, we're looking at the difference between the P ATM, or the pressure in the atmosphere, and the P pull, which is the pressure in the alveoli. And it's less than normally 2 millimeters of mercury or less during normal breathing. And so this overall pressure is more than enough to move about 500 mils of air. Right? And so gas flow changes inversely with resistance, right? So the less amount of resistance, if you have a lot of resistance, you're going to have a lot of gas flow changes, right? So resistance in the respiratory tree is usually insignificant for two reasons, though. And it's normally because we're looking at the diameter of airways. And the diameter in the airways, essentially in the first part of the conducting zone, are large. So we're not looking at a lot of resistance there, right? Now, as we go and go through progressive branching, right? As they get smaller, it tends not to be a problem because it leads to an increase in total cross-section area. And so any resistance that we generally see tends to be in the bronchi. Not at the beginning, because the areas are so big. Not at the terminal bronchioles, because we're having diffusion happen with the gas, so the gas is moving away, So essentially most of the resistance we see is in that middle area. So it tends to not be a really big problem in the respiratory tree. And you can see here, right? You have the conducting area, which is the area that basically oxygen is moving its way through to get to the respiratory area, which is that area for which gas exchange is happening. And so we have the largest amount of resistance in that medium. Obviously not here because they're big, right? Not here because O2 is diffusing into the body, right? It tends to be just right here in that middle area where the branches are just medium size. So because you're reducing that volume, you're getting some of that friction and some of that resistance, but it's going to mediate out the farther you go down, and basically the diffusion of gas is going to help kind of mediate that and make the oxygen go through those areas faster. The problem we can have is with the resistance is if something happens to increase airway resistance, breathing movement can become more strenuous. So you can get severe constriction or obstruction of the bronchioles, can prevent life-sustaining ventilation. And this can happen whenever you're looking at things like asthma attacks, right? Where there's a stop in ventilation. And so how do we fix this? You get some epinephrine. That's going to dilate those bronchioles, and it's going to reduce the air friction so that you can actually breathe. Now, alveolar surface tension is basically the attraction of liquid molecules to one another at a gas-liquid interface, right? And so what happens here is that this tends to draw liquid molecules closer together. And it's going to reduce contact with dissimilar gases. This is also going to help with resisting any force that tends to increase surface area of liquid. So essentially what we have here is we have water. And that water is it has a very high surface tension, which surface tension is just this idea that the water molecules attract each other or have really tight bonds, and the area for which it's exposed to something else, like the air or the oxygen, right? And so that's going to allow the water to essentially coat the alveolar walls. And so this essentially could be bad. Right? It could be bad because this essentially could cause the alveoli to shrink and collapse. But within this, we have what are known as surfactants. And in that, this is just body detergent like lipids and protein complexes that help to reduce the surface tension of the alveolar fluid. So this can, one, help to prevent alveolar collapse, and it is produced by those type 2 cells. Remember I said they helped with producing some proteins and lipids that could help essentially keep that area also kind of clean. Well, it can help to reduce the likelihood of surface tension causing a problem and making it so that the alveoli completely collapse. It kind of gives them a steady and makes it balance out. And the last part is lung compliance, and this is a measure of change in the lung volume that occurs with each change of pulmonary pressure. And so what is that? It's like, okay, what does that truly mean? It's like, oh my gosh, okay. It's a measurement of how much stretch the lung has. Right? And so it's normally high because the lung tissue there's a distensibility of lung tissue. There's also those surfactants that, if you remember, decrease alveolar surface tension that we just talked about. So distensibility is just this idea of being able to extend out or dilate or become bigger, right? So that's why you were able to have high lung capacitance, because your lung tissue is very elastic. And then because you have those surfactants that are being released, you kind of disrupt the normal water surface tension there. And so you allow it so that your alveoli do not collapse. So compliance can be diminished by scar tissue, right? And that's fibrotic tissue. So that has a lot more fibers like collagen versus elastin. And so it doesn't have as much give. So you're not going to be able to basically have this stretch. If you don't have as much surfactants, then you're going to have that increase in surface tension of water again, which is going to basically cause pressure to come in, and you're more likely to have the collapsibility of your alveoli. And if you have less of a flexibility in your thoracic cage, you're not going to be able to kind of have the flexibility where your rib cage opens more. So then essentially your lungs aren't going to stretch as much. So those, folks, are the three physical factors that influence the ease of air passage and the amount of energy that's required for ventilation. Now, the total compliance of respiratory system is also influenced by compliance, or this give or stretch of the thoracic wall, which is decreased by if you have deformities of your rib cage. If your costal cartilage actually ossifies, which becomes more common in older age, or if your intercostal muscles essentially get paralyzed or go through paralysis. And so at this point, I'm going to stop the video. The last part of this where is it?